This Week in Virology, the podcast about viruses, the kind that make you sick. From MicrobeTV, this is TWiV. This Week in Virology, episode 1295, recorded on February 6, 2026. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today from Austin, Texas, Rich Condit.
Hi there, Vincent. I'm trying to look up the weather here. You caught me by surprise. But, you know, it's sunny, and it's about 70 degrees, I think. And we're headed for, I think the forecast today was for the low 80s. So, it says it's 82. Holy cow. So winter's over. It's spring. Done. That was winter took a week.
Here it's -1 in Chelsea. It feels like -6. And tomorrow we have a extreme cold warning. It's going to be -15 and -17 on Sunday. That's
Holy
Celsius,
cow.
of course. It's pretty cold. And then Monday -14. And then all next week below sub-zero temperatures. We still have winter here. It's not over. Also joining us from Madison, New Jersey, Breanne Barker.
Hi, great to be here. It is also 31F, -1C here. We also are going to be quite in the cold next week, although it's supposed to warm up here later in the week. It's going to be above freezing for the first time in like a month.
I don't know. Here it's going to be, it says later in the week, which is Friday, -5. A week from today, -5.
What about Tuesday, Wednesday?
-9, -3, -4.
Yeah, that's not what I have.
It's all
Apparently we're keeping the heat in New Jersey.
Maybe you're inland. Maybe that's it. I don't know. Yeah, but you know, big cities are supposed to be inherently warmer,
Yeah.
but we have all these winds coming in. You know, I just noticed on our video here, the two people on the bottom are really freezing, and the two people on the top are warmer. So, joining us from College Station, Texas, Jolene Ramsey.
Howdy. Yes, it is warmer here, 77 degrees Fahrenheit, 25 C. But in my office, it's 72, which feels chilly. Obviously not nearly as cold as you have, and I am not sad that spring is basically coming /here.
If you enjoy these programs about science, we would love your support to continue them. You can go to microbe.tv/contribute. We don't have ads on our programs. They're all free. We want you to learn science from us, all different kinds of science, not just virology. And we would love your support to help support them. Rosenfeld Lab, as you have been hearing, has moved to Philadelphia. They are looking for a postdoc and a technician. They work on the cross-reactive anti-enterovirus immune response and what that means for pathogenesis. And they also try and make new vaccines. And so they want to make animal models to study these cross-reactive responses and try and figure out new delivery methods for vaccines. If you're interested in working on these things, you can go to, her email, Amy's email is rosenfelda@mlhs.org. And also coming up, you know, February has already begun. The months are just clicking along. And before you know it, it'll be July 27th through 30th. That will be ASV in Minneapolis at the University of Minnesota. The abstract deadline has passed, so Kathy has not updated these things. The travel award deadline, however, is February 9th. It's next week, and you have to be a member. So you should go to asv.org, make sure your membership is up to date. Register for the meeting, and if you want a travel award, you can apply for that. Okay, a little bit of news here. Who put in the measles update? Nobody. It must have been Alan.
Yeah, I don't know. But
So
South Carolina's measles outbreak continues to grow. We know the cases are up. Texas outbreak does not continue to grow.
Yeah. Just give it some time. It'll start growing again.
That's because my yoga teacher's on it.
Yeah, this is an NPR article. Measles continues to spread. We now have more cases than we have had ever since 2000, when it was eliminated actually in the U.S. Now it's all coming back, and most of these cases, the vast majority are in unvaccinated people who do not choose to vaccinate themselves or their children. And this is not good. Measles can kill you. It can make you forget your immunity. It can cause pneumonia, and in the long term, it can cause a degenerative neurological disease, SSPE. So it is really not good to not get immunized against anything for which there's a vaccine, actually, but now specifically measles.
One of the interesting things I think that was in this article is that this is not a problem that's confined to the United States.
No, it's not.
The measles is on the rise everywhere, and there are several countries. Maybe this is even highlighted in the paper that we're going to talk about that have lost their elimination status, and the U.S. is on the verge of losing its elimination status.
It will. Sustained endemic transmission for 12 months. That's it. And we have had that. So, folks, these are not imported cases. These are locally circulating viruses, right? In fact, it was a outbreak at 2 of the ICE detention facilities, one in Texas and one in Arizona. Not surprising, because the virus is circulating in those states. And the administration says, "Oh, these are filthy foreigners who are bringing the virus in." No, it's virus circulating in the U.S. And that's what happens when you don't immunize enough people. So there's just no reason not to immunize. People who say they want their medical freedom, that's BS. That's just an excuse. You have no freedom not to wear seatbelts, or stop at a stop sign, or stop at a red light, or not smoke here at the incubator. You're not allowed to do that.
Without consequences. You can do it, but there are consequences.
Yeah. You may not. You may not do it. And the consequence is even worse if you don't immunize your kids. They get sick, and they can get very sick and be hospitalized and even die. So come on, folks. To live in a society, you need to give things up. And this freedom business, you need to give it up for certain things.
And really, you're not giving up anything. You're gaining immunity.
I totally. It's a great trade-off, isn't it?
Right.
I think one of the quotes from a pediatric physician in this article is that it's really difficult to see these child patients because they're dehydrated, they have fevers, they feel bad, they're coughing and coughing and coughing, and some of them progress to more serious complications. We haven't had any reported encephalitis cases yet, but they'll be coming because it's just a matter of numbers, and our numbers keep going up.
Yeah, we've had 3 deaths. That's 3 kids who should not have died had they been immunized. So I have a news article from KFF, which I just found this morning. KFF is an independent source for health policy research, polling, and news.
They have amazing data. I use their data in a few of my classes.
So this was a poll finding, KFF tracking poll on health information and trust in the CDC and views of federal childhood vaccine schedule changes. So it's an article based on some polls that they have done. That's what they do here. Polling, one of the things they do. And so basically what you're going to see here is that the trust in the CDC has gone down, and it's gone down more among Democrats than among Republicans. And this just blows me away. This idea that the political party you are part of determines your position on healthcare. They have nothing to do with each other. Viruses do not respect political borders. So let's get some numbers here. Over half of Democrats, 55%, and 43% Republicans, and 46% independents, they say they trust the agency for vaccine information, but that's gone down. It's been a 9 percentage point drop among Democrats.
Well, yeah, it's actually interesting because the graph shows the data on the polling from January 2026 which gives the numbers that Vincent mentioned, but it also shows some previous polls, including one in September 2023. And it looks like there, Democrats had 88% of Democrats said they trusted the CDC, and now it's gone down to 55. Oddly enough, Republicans were at 40% in 2023 and are now at 43. It just seems odd. I don't like any of it.
It's just crazy that it goes by political party. It just doesn't make any sense.
Well, that just tells you that people are not following the science. They're following gobbledygook.
Let's see. About half.
I think the thing that is crazy to me is that it's half. It's like half of all people. I mean, yes, it's between 43 and 55%, but that's like about half. Yeah. Half of all people. And I mean, there's good reasons now not to really believe everything that is coming out or the lack of information.
Well, the ACIP alone, right? I trust them zero because they don't know what they're doing, right?
As they keep reducing the list of vaccines.
And the rest of the CDC, they fired so many people. Who knows what's going on there? I think they're underreporting a lot of things, frankly. And so I don't trust anything. I would rather hear from the states, which have especially the blue states, which are more trustable, in my opinion. About half of U.S. adults who report hearing about the changes to the childhood vaccine schedule say the changes will have a negative impact, 54%, on children's health rather than a positive one. So 26% of people think the schedule change is going to have a positive impact on children's health. And there was one point here where like 21% of people had not even heard of the changes to the vaccine schedule. That's not surprising, I guess. A lot of people don't pay any attention. Now, at least 8 in 10 U.S. adults across partisans and parents are confident in the safety of measles, mumps, rubella, and polio vaccines. It's interesting. And one of our papers is going to come back to this confidence thing again. I think I had seen another study done by the New York Times where almost 90% of adults were in favor of the previous childhood vaccine schedule, over 90%. Of course, it depends who you poll, right? And they don't poll the whole country. So it's very interesting.
So
anyway, so there's...
Go ahead.
No, that's okay.
This is a sideline. I was going to talk about KFF because I've been confused about that.
Anyway, I just want to just go check this out. This is really... it also has confidence in health agencies to act independently or make decisions based on science. It has low confidence there as well. Most of the public overall disapprove of Kennedy's job performance, but most Maha supporters and Republicans approve. So this is the thing. You have a majority of people in the U.S. who disapprove what he's doing, but yet the Republicans and the Maha supporters think he's fine. So obviously this is not being critical whatsoever. You're just looking at the party line, and that's not how public health is supposed to work. So a lot of interesting stuff here. I recommend you have a look at it. Okay, go ahead, Rich.
Well, I have been confused about what KFF is, so I looked it up. They describe themselves as the leading health policy organization in the U.S., a one-of-a-kind information organization. We bring together substantial capabilities in policy, research, polling, and journalism in one organization to meet the need for a trusted, independent source of information on national health issues, one with the scope and reach to be a counterweight to healthcare's vested interests and a voice for the people. And here's one of the things in particular that confused me that's resolved here. The organization was formerly known as the Kaiser Family Foundation. But since KFF is not a foundation and has no connection with Kaiser Permanente, we are now simply called KFF. Legally, we are a public charity and endowed national nonprofit organization, and give you links to more about their history. So that takes care of that for me, because I, confused it with Kaiser Permanente and et cetera. But they're an independent deal. They may have, I don't know what their initial connection might have been with the Kaiser family or Kaiser Permanente, but it doesn't matter because this is where we are now. Cool.
Okay. Let's do a snippet, which is basically about measles also. This is a paper in the Journal of Virology. Measles vaccination perceptions and willingness to consider novel vaccination approaches in Cambodia's floating villages. So I saw this title and I said, we have to talk about this because
I was going to ask how you came up with this. This is good.
I was just going through JV because sometimes you get interesting stuff in JV. And I saw this and I saw Eric Carlson. So he's been on TWiV. We did an episode in Australia at Options for Influenza meeting. I wasn't there, but I did it via Zoom. And he works in Cambodia for the Institut Pasteur. It's really interesting. He aside from what he's done here, he does all kinds of surveillance because there are live markets there, and they want to know what's going on in these live markets. And then I thought this is interesting because we're always talking about vaccine uptake in the U.S. or Europe, but hey, Cambodia, and I know zero about Cambodia, and so I thought, let's see what they think about vaccines. So the authors are Benjamin Sievers, Sudipta Haider, Malen Chan, Sawath Lee, Lee Sovan, and Eric Carlson. So they are, I don't know where they are. Are the authors all at the end?
They're at University of Kentucky College of Medicine.
Yes.
For Eric Carlson. For Benjamin Sievers, he is at the Virology Unit of the Institut Pasteur in Cambodia and the Department of Medicine at University of Cambridge in the UK. The second author is at Columbia Irving Medical Center. Then we've got the Institut Pasteur in Cambodia for the other two authors, and the Communicable Disease Control Department, Ministry of Health in Cambodia.
Okay, nobody's in Kentucky. That's the editor.
Okay.
Yeah.
So Carlson is in Cambodia.
Yeah.
And then Columbia Irving Medical Center.
So if you look at the distribution of what's been done, it's clearly this is centered in Cambodia with some help from others in Cambridge and in Columbia and elsewhere.
Yeah, probably Columbia, they did the statistics. And of course, the data collection was done in Cambodia. Anyway, did you know that measles still kills over 100,000 kids annually? This is a shame. This is a bloody shame.
Yeah.
It's huge. And, we have vaccines that will prevent death, but it's hard to, in some countries like us, they're being discouraged by public health leaders. And in other countries, they just can't get them. They don't have the infrastructure and so forth. And there have been, COVID interrupted measles vaccination programs for sure. And it's been hard to recover from them. Many parts of the world don't have, centralized vaccination services. And in particular, the Western Pacific region, both Mongolia and Cambodia achieved elimination in 2014 and 2015, which means no endogenous circulation for a year, but disruptions in vaccination, and then importation of virus, and then pockets of unvaccinated people have led to resurgences, which is what we're seeing here in the U.S.
I see repeatedly in these articles that a major disruption in vaccination was the pandemic, which certainly makes sense.
And the thing is, not only did it disrupt vaccination, but also data collection. So we don't even know the impact, the full impact.
It also impacted on this issue of trust in public health, at least in some places.
So Cambodia brings us to Cambodia, which is, of course, in Southeast Asia. They say it is a least developed country. I guess it would be a lower income country, right?
Yes.
And then there's a floating community. It's called Prek Tol in the Battambang province in northern Cambodia, and it is home to 13,823 people. And they have a picture of the community here. There's a lot
From the
it's
air.
all water from the air, and it's all water, and there are houses and trees and Jolene says the houses are on stilts. They're not
Yes,
really
I
floating.
looked it up because I was curious about this floating community idea. And they have a dry season when the houses are on stilts, like they look like they're very tall up in the air. And then the rainy season when the streets are completely turned into boatways and they get around by small watercraft.
Can you imagine sleeping and you hear the water lapping under your house? I couldn't sleep. I once stayed in a house on stilts and it just kept swaying all night. I could not sleep. It was up in Western Canada.
Everything you're talking about is like sleeping on a small boat. It sways all night and you can hear the water lapping up against the hull.
Yeah,
That's
the
right.
water sounds peaceful, but the swaying of the stilts does not.
It's very disorienting, I can tell you. Anyway, this area is a preserve. It's Tonle Sap Biosphere Reserve, and there's a lot of diversity. A lot, these forests and bird sanctuaries, a lot of wildlife, a lot of migratory birds, and so that people do a lot of fishing and farming there. But there are also risks for zoonotic spillovers, right, from these animals, and that's something that Eric Carlson works on. But also, the idea of a floating village, they say, complicates disease control and healthcare access, right? So these communities are particularly vulnerable to infectious diseases. Now, as far as measles, Cambodia has a good measles program. They got elimination in 2015, but because of the pandemic, they think measles could reemerge, especially in hard-to-reach communities like the floating communities here. In 2019, there were 676 confirmed measles cases in Cambodia, many of them in the floating villages. And then in 2025, there were 375 cases. And in 2024,
I think in 2024 they had 375, and in 2025 they had 2,000.
2,000.
And big increase.
Yeah.
So there are 2 doses of measles vaccine, and the first and second dose coverage is in 23 anyway. It was 79% and 64%.
And you need, in order to stop transmission with measles, you need about 95%, I think.
Yeah.
It's one of the most infectious diseases out there. I looked up the R0, and it's debatable, but they talk about numbers from 12 to 18, meaning that a single individual, on average, may infect between 12 and 18 other people. So, you don't want to be around unvaccinated when measles is around. You're going to get it.
So most of the vaccination in Cambodia is done at centers, hospitals, and health centers. But these floating communities, they're less likely to visit those, and so they're particularly susceptible or vulnerable. So that's what this paper is about. It's a survey of people who live in the floating village to try and understand their views on vaccination. So they give individuals a questionnaire. It's 12 questions. Whether you strongly disagree or strongly agree. It's a scale, and it's called the Vaccination Attitudes Examination, or the VAX scale. And they look for parents and guardians with 1 or more children living within this floating community. They initially looked at 385 people and ended up having 200 respond because a number of them were unreachable or had the wrong contact. So that's not everybody's represented here. And then the studies were analyzed statistically, and that's what we have. So the results, 200 people, it's just interesting, 62% women and 37% men, overall mean age 36, 11% guardians of children, 40% completed primary education, 35% secondary, and 25% no education. And in general, they had a positive attitude towards vaccination. Most of the people, 93%, agree that vaccines are safe. 90% believe they are effective at preventing disease. 58% did have, and that's good, that disease, right?
Yeah.
58% had some concerns about side effects, but it didn't diminish the overall support. Opinions were split about the belief that natural immunity lasts longer than vaccine-induced immunity, natural being infected, right? 52% disagree and 48% agree.
You want to know what I think about that particular number?
Yeah.
In some ways, I kind of look at that and I'm like, that might be the percentage that I would think for immunologists too.
You think so?
I could make arguments on both sides of that one, and I think it depends on the vaccine and the pathogen. But as I look at that, I'm like, you know what? I don't think they're that far off. I
don't know that. What pathogen would you prefer over the vaccine?
I didn't say.
Well, that's different, right?
I didn't say whether I'd prefer the pathogen. I'm saying specifically
Does
lasts
immunity
longer.
lasts longer?
The immunity.
Yeah, I mean, that's one thing, but the cost you might pay for that is bad,
exactly.
right?
I'm very much specifically on the last longer. I'm like, yeah, I might give you guys that one, but I also agree with you that they're safe and effective, and you shouldn't be concerned about the side effects, even though you might have them. I'm kind of on board with many of their responses.
Yeah, I think one thing that a concept that people have difficulty with is risk benefit. Okay.
Yeah, for sure.
That which would you rather have, the disease or the vaccine? And that for some people that one's hard to evaluate, deal with.
So, what would you rather have, rabies or rabies vaccine?
I mean, I don't think there's anything I'd rather have the disease than the vaccine.
No case.
I'm just saying, if we're talking about, persistence of immunity, maybe I'd give a little bit of a positive there.
Yeah, there's some very, very long-lived, especially for systemic pathogens.
Right, exactly.
You get many, many years of immunity, and it's not clear that vaccines are going to last that long. But, I'm not sure it's such an important question. The question is, would you rather be infected or vaccinated?
Right.
I would love to see their answer to that.
Yeah, I would. Yeah, in the table, they call it natural exposure is better.
Mm-hmm.
Yes.
Or natural, and they also have natural immunity is better. And so I don't actually think, though, I would not say yes to that.
Yeah.
But I might say yes, but it's the last longer part.
I don't know. So that's kind of vague, is better.
Exactly.
Right? And a lot of people agreed to some level, right? You have your slightly agree, and strongly agree. And more people think natural exposure is better than don't, right? It's good to be exposed.
I think that if they had phrased it something like, getting sick is better, then you might have a different response,
Yeah, these are...
Because the word natural sounds good.
Yeah.
Yes, it is. Yes.
The questions are much more nuanced than is going to come over, be communicated in a survey.
Yeah, I tried to just click on the paper that they cite with the survey to see how it was phrased in the survey, but it looks like I'd have to do some work to get access. I can't access it. But at the same time, they also took the survey from this paper and translated it into Khmer as part of the study. I also do not read Khmer and don't know if the way they phrased it, what that connotes to a native Khmer speaker.
Yes, these are on this figure 3. These are not the questions they asked. This is just a summary, right? I'm sure the question is a bit longer. So, but they do say here natural immunity is better, and that kind of split either way. But what's really interesting is that 92% of the participants strongly rejected the idea that vaccines are designed for financial gain rather than public health protection. So I think that's very interesting.
My take-home message from this is a pretty enlightened group of people.
Yes, exactly right. I have the same reaction. It's really remarkable because they're kind of isolated. I don't know, maybe they must have internet, right? So they're up on stuff.
Yeah, they probably have internet. I wonder how much of this is, not getting some of the unfortunate misinformation.
Yeah.
And how much of it is maybe having a little bit higher burden of other infectious diseases and sort of seeing the effect of vaccines in their daily life more often.
Another good point. Yep. Absolutely.
Yes, I think they are pretty much immune from the anti-vaxxers because it's not a big enough population for them to bother with, right? Because the anti-vaxxers want to sell you something. They want to sell you an alternative product, and they're not going to sell these individuals anything. Although,
Well, I think they
RFK
want a
Jr. went.
following, right? Like they want a following. It's a lot of it is about the money, and some of it's just about attention and momentum.
Yeah, I guess this doesn't fit the bill for them.
But
But I think
there are a lot of truths to the statement that vaccines are made for financial gain. It's because they are, and that's why we don't have vaccines against a lot of diseases. Is because there will be no financial gain.
Well, yes, but that's not really gain. It's paying off the cost to make the vaccine, right? So
Initially,
you have to pay it. I mean, manufacturing still has a cost associated with it, and
Sure.
so you have to always take care of that. Otherwise, you lose money.
And
right?
you could say they're for financial gain of not having to pay for healthcare resources when you get sick.
Yeah.
So yeah, sure, there's a financial gain, but there's also a bigger immunity gain.
We were talking about this on Clinical Update yesterday, and Daniel says doctors do not make money on vaccines. So this is doctors, not the companies who make them. They basically break even. They buy the vaccine themselves, and then they charge you to get it.
Mm.
But companies have always, over the years, I mean, most companies would rather not be making vaccines because they litigation, they often can lose money.
they don't make a big margin on those vaccines.
Right, I think that's
And
true.
it's a one-shot deal, right? Or a couple shots. It's not a thing they can sell you for your whole life because you have to take a medicine. It's a few times in your life. And so that's not a great pharmaceutical market. But, the anti-vaxxers will argue that we're lying about it and they make tons of money. But it's not true. They don't. So
I would like to know where my check is in that case.
Right. I think these people haven't heard that contaminating argument, right? They haven't been brainwashed by these anti-vaxxers.
They don't
That's
have
really
time
good.
for that, really.
Yeah,
You
that's
know?
true.
They got other stuff going on.
I think the question that is summarized, vaccines are part of a conspiracy, tells you that if they've heard it, they just don't care.
Yeah.
They also 95% were familiar with measles virus. That's cool. And 86% had children who received the measles-containing vaccine. So that's a low number for measles.
Yeah.
And finally, they asked them about their attitude on self-vaccination. So would you immunize, not necessarily with a needle, but with something that can be self-administered, like a micro needle patch or something you inhale, right? 89% of respondents expressed willingness to administer vaccines to their children if given proper instruction. However, 92% indicated they preferred to have a healthcare professional administer the vaccine. That's very interesting.
I had the feeling that aspect of this paper was a significant motivation for doing a study to start with.
I had the same feeling.
Is that, there's no point in considering a self-administered vaccine if the population that you're trying to recruit, is anti-vax or completely unknowledgeable. But if they're receptive to
or is sketched out about a self-administered vaccine.
I can imagine, you're trying to go with a self-administered vaccine to an anti-vax crowd. They're going to think you're feeding them Kool-Aid, right? You're trying to kill them. But this is not that. And in this regard, there's a couple of things that came up that struck me. That for future investigation by us, a recent clinical trial in Gambia demonstrated that measles and rubella microneedle patch vaccines were highly safe, well-tolerated, and immunogenic in children, offering a promising alternative to traditional subcutaneous vaccines. And they give a reference to that. That would be an interesting paper. Because we talk about these microneedle patch vaccines occasionally, and they're obvious candidates for this self-administration. It would be interesting to see that. Then there was another one. This is not directly on topic, but still. Paragraph down from that. In Zimbabwe in 2022, Over 700 children died of measles infections during an outbreak, largely fueled by under-vaccination due to rumors and misinformation circulating in the media. They give a reference to that. That would be interesting to discuss as well.
Yeah, you could see how misinformation could be a real problem because, with the educational level that we see in this community, they might not know what to think of it, and then just be negative to be safe. So it's very dangerous. Yeah.
You could also imagine, just like we think about sometimes here on TWiV, that the way you go about that conversation is probably important. If you go into that conversation saying, "Hey, you stupid person, you got to go vaccinate," you're probably not as likely to have them, be as receptive as if you are actually talking to them and being a human yourself and thinking about them as a human and maybe having something in common with them, things like that.
I do think, though, in some populations, maybe, so I would say in the U.S., making vaccination easier might get you a certain percentage of the anti-vaccine people.
Then you go into a closet and do it when nobody's looking.
No, not that, but just, I think it's been suggested that a good part of anti-vaccine sentiment is because it's hard to bring kids multiple times to doctors. And if you did something like immunized at schools, that would help a lot with many parents.
Right. And
not
maybe,
everyone.
And you get around the needle fear too.
Yeah.
Yeah. And then if you have a microneedle at school, that would be great because the needle, I think needle fear is a big part of it as well.
A lot of people don't like injecting their babies with so many things, but if they were to put a patch, that doesn't hurt. They don't cry.
Yes, right. Crying baby makes you feel very bad. But this community seems pretty enlightened, so hopefully they stay that way and not get contaminated by misinformation, right? But maybe they're suspicious to begin with, which more so than Americans. That would be great. I shouldn't say that because a lot of Americans are pro-vaccine. It is a relatively small fraction who actually don't vaccinate their kids.
We can go back to that KFF and get the numbers.
Yeah. Yes. Well, that was trust, right? But I would say almost 90% of the U.S. are in favor of the old vaccine schedule, which means they would immunize their kids, right? So they say these findings demonstrate a critical opportunity to reimagine measles vaccination strategies in response to a global resurgence, which is, of course, what we're having now. Innovation must be paired with trust, community engagement, transparent information, cultural sensitivity, and respect for local preferences in designing and developing methods to increase vaccination coverage. I like this transparent information. Gee, didn't we hear that somewhere else? We want to increase transparency, and then all you're doing is making things more opaque.
It's one thing to say it. It's not always so easy. I think even if you make information available, people don't understand. They don't have the framework to interpret all the information on safety and the way it's designed. So I think the most impressive thing I took away from this is their trust in their healthcare system.
Yeah, it's impressive.
Because most people I know like to do their own research before and after they go to the doctor here. Yeah, it used to be the Google search, and now it's like the AI enhanced Google search.
Yes. Just ask ChatGPT, what should I do?
Right.
What should I do? Okay, I thought that would be fun, and I think it's informative.
Like that. I enjoyed that.
It's a community we never talk about, right?
Mm-hmm.
So I think everyone deserves attention, and everyone's different. Every community is slightly different. One vaccine doesn't fit all. One vaccination strategy doesn't fit all. Okay, now for something different, Jolene is going to entertain us.
All right, I am going to talk about phage. Surprise! And
you probably could guess that, right?
Sometimes I actually think like, I see other articles and I'm like, oh, this might be interesting for me to do on TWiV. And I'm like, no, got to pick phage.
What would happen if you showed up and did a non-phage paper? Wow, that would be scandalous.
So
I don't
this
think it would be
paper
scandalous.
is called
just
A
joking.
Prophage Intercepts Pathogenic Activity of Infecting Phage for Defense. It was published in Cell Host Microbe just very recently, 2025. And it just has 2 authors, Molly Sargan and Sophie Helene. They are at Harvard Medical School.
That's amazing. 2 authors.
I know. And Molly was a graduate student when she did this work. So
Wow.
it's a very nice story. So kind of in a nutshell, I see this as an encapsulation of the warfare and competition between phages. Most bacteria have multiple prophages in their chromosome already integrated, and they are competing with each other for limited territory, limited host cells that are available. And here they've discovered a couple of different mechanisms by which one prophage that's already integrated is kind of staking its territory in a way that protects the rest of the population from another phage that might be activating or infecting. So I really love so it's like a defense paper, except it's like a phage defense against another phage. And I generally steer away from defense, even though that's a huge area that's ballooning in phage research right now. But this one really caught my eye because it has to do with lysis, which is like my favorite area of phage biology. And it's in a different bug than I usually study. So this is in Salmonella. They were looking at the different kinds of abortive infection systems. So abortive infection systems are when there is an infection of a cell, but something happens to prevent completion of the infection and release of phage. And abortive infection systems can kill the cell, or they can not kill the cell, but they're directed at blocking replication of a phage. They can include things like cutting DNA or RNA, depleting ATP, or inhibiting transcription or translation, all of which are things that the phage would need to complete its replication cycle. Many of them are on kind of like surveillance systems all the time, and they're frequently encoded by bacteria. And sometimes they can just be activated when a phage protein or RNA becomes detected inside of a cell. So the particular kind of abortive infection system that they're looking at this time is encoded by a prophage, which is in the genome. So this prophage is integrated into the chromosome, and it functions with just a single gene. But they actually found 2, and they're just single genes. They were first looking at a prophage that is called GIFC3. It's a family of a few different GIFC prophages. These are lambdoid prophages, meaning they are double-stranded DNA in their virion. They're about 50 kilobases long. They have a flexible tail, and they have also several. So because they're lambdoid, we know a lot about some of their genes that are well characterized. But these GIFC phages are interesting because they have unique regions that seem to have genes associated with either defense or virulence of their host. And
Hey, Jolene?
Yeah.
I'm thinking that it might be useful to do in 50 words or less lysogeny so that people understand what a prophage is.
Yes.
And what's going on here.
Okay. So these are prophages, which means that the phage will infect the cell, and then instead of immediately beginning active replication, host takeover, make particles, and lyse the cell, they will go into a quiescent state. And that can be either directly integrated into the bacterial chromosome or as an extra chromosomal element. And they will be replicated generally passively by the host or just at a very low level outside of the host chromosome. And they can lay in that state for many, many, many bacterial generations. They can then be reactivated by different environmental signals. A very common one is DNA damage will cause the prophage to activate into its lytic cycle and produce virions, escape, and make virions that can plaque again.
Yeah, so I feel like these things are kind of hanging out in a quiescent state, and it's in their interest to monitor conditions in the cell all the time to decide whether they ought to stay there or break out, and also protect themselves from other invaders and indirectly protect the cell at the same time. It's a very interesting dynamic.
Yeah. Most of the genes of prophages are completely off, but they have certain genes that are on. Those are the repressor genes that prevent most replication. And then they have other genes that can sometimes confer new properties to their host. So sometimes they are virulence factors. And then they have other genes that can sense the state of the cell.
So they have ways of sensing DNA damage, for example.
Yeah, usually the repressor is tied into the repair system of the cell.
The repressor being a constitutively synthesized protein that keeps all these other genes inactive in the prophage, right?
Exactly.
Yeah.
Right.
It's
Yeah.
so cool.
Julie,
So-
you said something about like one protein or an encoding of one protein
Yes.
earlier, and I didn't quite understand what you were saying there.
Okay, so we're going to get to how they're looking at the interactions between this GIFC3 prophage that's integrated into Salmonella and 3 other prophages that are also integrated into this same strain of Salmonella, and then one other phage called Felix 01. So what they saw was that GIFC3 prophage strain, lysogens meaning hosts with GIFC3 integrated, they were able to restrict plaque formation by various other phages, including Felix 01, which is a very broadly acting phage against many different Salmonella strains, and another one called BTP1, which is also integrated into the same chromosome as GIFC3. And then what I was talking about with one protein is that they found that there are 2 different systems that GIFC3 encodes. Each of them makes a single protein, and that single protein helps defend the cell against those other phages that are trying to infect or replicate. Yes. So the first thing that they did was they looked at cells that have GIFC3 integrated, and they just tried to plaque Felix 01 and BTP1 phages. And they saw that they didn't get very many plaques at all. And they knew that the relative GIFC1 encoded an ATPase, and they saw that there was something that looked like the ATPase in GIFC3. And so they deleted that ATPase-like protein that is called REM-S. And then they regained plaquing efficiency for both Felix 01 and BTP1. And if
these ATPases have a history of participating in this kind of thing, right? So that's why their attention was drawn to it.
Yes, because ATP is vital for cellular functions, and it's absolutely vital for the phage to be able to complete its replication cycle. So it's known that if you turn on an ATPase and deplete ATP levels in the cell, that on its own, it can kill the cell. Perhaps the cell can recover from that. But if you delay the phage replication cycle long enough, then the host enzymes can degrade its DNA, and then they're no longer going to be able to replicate. Right. So they started to look at this REM-S gene, and when they deleted it, they regained plaquing efficiency for the ones that weren't previously able to plaque very well on that host. And they showed that if you infected these GIFC3 cells at a low MOI, when this REM-S system was present, then the host kept growing. So it was protected because the GIFC3 REM-S system was there. But if you didn't have REM-S, the host died. So it wasn't protected. And they looked at the REM-S protein. It had the classic motifs, Walker A and Walker B, that are known to be involved in ATPase activity. They mutated the residues. They mutated the nucleotides that encode for the residues that are in the active site. And when they did that, they could no longer protect the cell against the GIFC3 could no longer protect the cell against the other phage.
Nice phrasing.
Trying to be accurate here. So that was the first system that they found was REM-S. It seemed to be involved in cleavage of ATP. And when the cell didn't have ATP, it would not really support the production of the other phage.
Actually, in reading this, I hadn't paid any or really noticed that multiplicity experiment. That's really good. Okay, because this notion of protecting defense taking the form of dying doesn't necessarily immediately make sense, right? It's like falling on the hand grenade, right?
Yeah.
These cells are killing themselves. They're committing suicide for the sake of the population. So in the multiplicity experiment, if everybody gets infected, everybody dies. But the low multiplicity infection shows you that the death of a small fraction of the population can preserve the rest of the population to keep replicating. I like that.
Yeah, this is where my idea of like being willing to go down for the ship was kind of trying to help me understand what's going on here. So how the lysogen is harboring a prophage. The prophage can protect the population. It can, some abortive infection systems protect that cell. This does not seem to be protecting that cell. But by sacrificing that one cell, the rest of the population of lysogens with the same prophage integrated now have the opportunity to replicate that prophage, GIFC3. So how does that get selected? I think you just have to have big numbers and lots of time, because the one that is doing the protection is not replicating.
Good point.
Right.
Yeah.
Yeah. That kind of tripped me up the whole time. I was like, but does it actually? And they do. There is an experiment later where they look at, there is some production of GIFC3 that is occurring, even when the cells are dying. So I think that might have something to do with it.
You know, the important thing is to be able, to me at least, is to be able to look at this whole thing on a population level. We have you're drawn to thinking about this stuff on an individual level, but at a population level, I can imagine how the evolution would go on.
So let's look at the ATP. As you said, it prevents the phage, the incoming phage, from replicating because ATP is low, right?
Yeah,
and that also kills the lysogen, right, at the same time.
Yeah, it can. There are some. It kind of depends on the level of activity and the amount of time before the cell undergoes other changes, I would like to say, because there have been some studies that show that cells can recover from basically like losing all of their ATP. So it depends on if they lyse open. If they lyse, then they're done. Yeah, but if they stay intact and there is enough time, they might be able to recover. I think in this case, they do not recover. Right. Because of the second system.
I can imagine too that there are phage that do so much damage to the cell by the time all of this happens that not necessarily because of the ATPase, but because of the phage itself. Yeah, you induce the ATPase and maybe inhibit the phage production in its late stages. But what happens during the first stages? The cell's on its deathbed anyway. Okay.
Yeah. Yeah, so some phage, like T4, will completely degrade the host chromosome. So that guy's not coming back. That cell is toast. But some don't really do a lot. Most of them encode a division inhibitor. Many of them will modify and recycle some of the components, proteins and nucleic acids as much as they can. But others, they come in and they do minimal damage to cellular machinery and chromosomes. They just kind of ignore it and they just use what they need.
Yeah, you sort of mentioned this already, but I guess part of what we're talking about is also if you're doing that defense and sort of taking one for the team in terms of the population, there's also this question of how fast are you at getting into lysis, or how fast are you at making a particle? Can you make like one last particle to go out and infect other cells while your cell is breaking down, or that one last gasp or not? And you sort of mentioned that they're measuring to see if there's any little bit of phage coming out. And so I think that is a hard thing to look at, and also is sort of a key part of this debate about, well, if you evolve to even get out one particle, then that might be okay.
Right.
But one's probably not enough, right? Because it may be broken. So you probably need to make a bunch. And that's where the ATPase comes in. If you could just prevent a critical number of phages, then you protect the population. That's what we're talking about here, right?
Yeah. Yeah. And that idea of one is not enough. I think in phage, the general dogma is that each particle is infectious. There is a 1-to-1 particle to PFU
For
ratio.
all phages, really? Yeah.
That's it. That's a general dogma. So to kind of explain that, every virion that gets assembled inside the cell that is complete is thought to be infectious. Whereas with eukaryotic viruses, many of the times it's like 1 in every 10,000 or 1 in 1,000 or maybe 1 in 100.
Yeah.
I don't actually believe that dogma, but it is closer to 1 than many of the other viruses we talk about on TWiV.
Then you have to be 100% in preventing production of viruses. That's tough, I think, right?
Yeah.
Biology, 100% is always tough.
Right. And I think it's more a balance. It's like who's just got enough of an edge to replicate.
Yeah. Yeah. Okay.
Okay. So they found this ATPase, and it is protecting the cell, or it is protecting the population from a second phage. And then they noticed some differences between GIFC3, which is the one that encodes the REMS ATPase, and GIFC1. So GIFC1 does not have REMS, and when they put REMS into GIFC1, it didn't protect. It did not protect. So they're like, oh, well, maybe there's something else in the GIFC3 genome that was necessary for REMS to be fully effective. And they did a couple of things to try to sort this out, but they moved GIFC3 and GIFC1 into different backgrounds, and they basically saw that as long as REMS was associated with a GIFC3 in any strain, then the defense would work. So the next thing they did was they started removing the regions of GIFC3 that were unique to GIFC3 compared to GIFC1. And they found just two segments, really, the segment with REMS, and then another segment that includes the genes that are involved in lysis, or escape from the cell. And they saw that there were the classic set of lysis genes. So the classic set of lysis genes for a double-stranded DNA phage are a holin, which will poke holes in the inner membrane, and an endolysin, which will degrade the cell wall of the bacteria. And there is another set of proteins called the spannins. So Salmonella is a gram-negative bacteria, which means not only does it have the cell membrane, and the cell wall, it has an outer membrane. And so these spannin proteins remove that outer membrane barrier so that the phage can escape. So
It's a complicated barrier.
It is.
So it takes a lot of ingenuity to break out of this sucker.
Takes a lot of evolution.
Yeah.
The phage are highly tuned to the barrier they have to get across.
I was just thinking that I had, when reading this paper, enjoyed the name of this new gene that they described. I thought that was clever. But I also think that Holin that you just mentioned is equally clever. So good job to whoever named these things.
I like pinholing.
Yeah.
It's good.
Yeah.
But
Yes.
one of them is poke, right?
Yes. Well, so poke.
Is it poke or pokey?
I don't
Okay,
know.
you got to catch them all, Brienne.
I don't know. In my head, I was calling it poke instead of pock-e, which would have been my classic way of reading the name. But pokey is nice. Maybe I'll call it pokey.
That's what I was thinking. It was pokey.
Because you're thinking of Pokemon.
So in the middle of these classic genes known to be involved in lysis, they found another gene, which we're calling pokey. So pokey is not usually in the middle of the lysis genes. So they started to look at whether that was what was responsible for this REM-S-mediated GIFC3 protection of the host. And they did that by deleting the entire lysis cassette of the holin, endolysin, spannins, and pokey, or just deleting the holin and the endolysin. So why did they do that? Because due to the lab conditions in which these infections are happening, those are the only two that are absolutely required to lyse the cell. So the holin it's a membrane protein, and it will accumulate in the inner membrane until it reaches a critical threshold concentration, and then it will rearrange to form holes. Those holes are the necessary trigger to release the endolysin. They also depolarize the membrane, completely depolarize the electrochemical gradient across the cell membrane. And as that occurs, there is release of this endolysin protein into the compartment between the membranes so that the endolysin can degrade the cell wall. If you're growing these in the lab, you don't always need to have that last set of proteins to remove the outer membrane because we shake them in flasks, and the shaking itself is sufficient to disrupt the outer membrane in specific media conditions. So here they deleted the essential holin and endolysin, and then they tried deleting the pokey and the spannins, or just pokey by itself. And they saw that when they deleted the entire lysis cassette, the BTP1 could replicate, so the host was not protected. They saw that when they deleted pokey and the spannins, BTP1 replicated, and when they just deleted pokey, BTP replicated, host was not protected. So it looked like just the pokey in the presence of REM-S was what was necessary, because when they got rid of REM-S, then the host was not protected. So it was a cooperation between REM-S and pokey. After that, they started to look at what is this pokey gene making, what kind of protein. And this is where it became even cooler for me as a lysis person, because the pokey gene encodes another holin protein. So as Vincent mentioned, there are different names for holins because they have different kinds of hole sizes. So the canonical holin makes a very large hole. In lambda, where it has been studied, this hole can be microns in size, so it's like very large. This holin is a pinholin, which means it makes very small holes. In the classic phage, where it has been studied, phage 21, the holes are 2 nanometers in diameter. So it's really just big enough for protons to flow through so that the membrane can be depolarized. And pokey, they think, is a pinholin. Again, being a lysis person, their rationale given is not maybe the most logical, but it does seem to exhibit Holin activity, which is what they started checking next. So they first took their GIFC phages where they had deleted the lysis genes and or POKI, and they induced and showed that if they didn't have the genes that were necessary for lysis, then they did not get lysis. And also, if they deleted POKI, they still got lysis. So POKI was not necessary for GIFC to be able to get out of the cell. It was an extra gene. And then they did something very important, which was they checked to see that POKI had the typical properties of a Holin. So a Holin, when expressed by itself, it doesn't need any other help. It will accumulate and then make holes, which kill the cell, because the cell, when it doesn't have its electrochemical gradient, cannot make ATP. So when they turned on POKI by itself, just like when they turned on the other GIFC Holin, the cells did not survive. They died. And you can see that they did it by multiple measures. POKI is acting just like a Holin. They also, this is where they checked between BTP1, which was the second invading phage, and GIFC, how much actually got made in the presence or absence of REM-S and POKI. So first, they check BTP1, and they see that when they delete REM-S by itself, they just get a tiny little bit more BTP1 than if REM-S is there. When they delete POKI by itself, they get a lot more BTP1 being produced. And when they delete both of them, it's a similar number of BTP1 phages that are being produced. When they look at the GIFC yield in the same conditions, so GIFC doesn't really go down if you delete REM-S. You get the same amount of GIFC. But when you delete POKI and POKI plus REM-S, you get a lot less phage, PFUs coming out of the cell. So it looks like there is some GIFC coming out, but it's not a lot. It's actually really hard for me to compare between these because they're all ratios instead of giving us raw numbers. Now, here this indicated to them that POKI and REM-S were working together. POKI is a Holin. It's a second Holin that is in the lysis cassette. It's not necessary for the phage to get out. So how in the world is it regulating? Like, how is just this Holin regulated by the infection with BTP1 is what they wanted to look at next. So it's known that these lysis genes are regulated transcriptionally as late genes via an anti-termination mechanism. So during transcription, there is the polymerase encounters a stem loop that causes transcription to terminate early before it even gets to the genes. So you don't get productive mRNAs being made. But the phage then, when it's ready to make lysis genes, it produces a protein that is an anti-terminator. So this anti-terminator protein called Q binds to the stem loop, unfolds it, and anti-terminates. It allows the transcription to complete across that region, and you get full mature mRNAs. So being lambdoid-like phages, GIFC3 does have a Q protein. And let's see here. So GIFC3 has a Q protein and BTP1 has a Q protein. They're not identical to each other. And that's really important because even between the classic lambda itself and lambdoid phages of E. coli, if the Q protein is different, they don't bind to the same same terminator loop. So they looked at the GIFC3 and BTP1 Q proteins upstream of the lysis cassettes, and they saw that they were different from each other. And they started looking at how they could get around BTP1 not being able to replicate. They basically selected for phage that could replicate even in the presence of REM-S and POKI. And then they sequenced those phage, and they found that there were mutations in the Q gene. And those mutations in the Q gene, they were able to test those to see that they were conferring resistance to POKI and REM-S. They did this a couple of ways. In addition to the plaque assays that they had been doing, they made these reporters on the chromosome. They put a GFP gene in a couple of locations. They put it at the beginning of the lysis cassette. They put it after the POKI gene, or kind of in the middle of the POKI gene, and after the POKI gene, so that they could see if the Q protein was binding, what part of the transcript was being made more or less. Was it the entire lysis cassette, or was it really just focused on POKI? And they did see that the Q protein from BTP1 was stimulating more POKI transcription specifically. It didn't stimulate more transcription of the upstream genes in the lysis cassette, just the POKI gene and what was downstream of it. And if they put the reporter after POKI, they didn't get more transcription. So it was really focused on the region where the POKI gene was.
And so this part to me was the really important and really fascinating part.
Mm-hmm.
Because if you think about it, you imagine this POKI gene. In some ways, it seems like a really useless thing for a phage to have, because it's going to just kill the host cell when it doesn't want to. But the idea is that it's off all the time,
Mm-hmm.
and has the ability to detect other phages.
Yes.
And so this ability to actually bind to the Q protein that varies from phage to phage of someone else. So if someone else's Q protein is around, you suddenly turn on this transcript, is really useful. If you turned on this transcript every time there was a Q protein, you would have what they call, which I thought was sort of an interesting phrasing, autoimmune reactions, where you basically also kill the population because you detected yourself.
Mm-hmm.
And so you want to make sure that you're not detecting, your own phage coming in and potentially, and then shutting down the population or making changes to what's going on. You only want to detect others. And I really loved this mechanism of there's this Q protein that varies from phage to phage. And that's how, and detecting other people's Q protein is how these phages are able to sense other invaders.
It's probably early in evolution it did, and those guys are dead, right?
Yeah, I mean, if it was not conferring the advantage for GIFC, it would not have been retained.
Yeah.
So the thing this is the part that makes me not so sure about how it can select for GIFC3, because they say, and I agree, it's logical that REM-S comes on relatively early, kind of gets rid of a lot of ATP, but if the second phage, if BTP1 can make its Q protein, that means it's getting ready to lyse the cell. It has gotten pretty late into its infection cycle. So this is a second place where GIFC3 can detect that stage has been reached. It turns on this pinholin, and that will kill the cell. It will kill the cell, but not lyse the cell, so that any BTP1 phages that did get made don't get released. But in that case, also any GIFC3 phages that might get made wouldn't get released. But if just the POKI gene is being transcribed, the rest of the GIFC infectious program has not gotten going, and I don't know how it's going to activate GIFC3. So there must be like some independent mechanism that turns on GIFC3 if it's getting turned on at all. Okay.
I kept thinking about, I don't know if we're really ready for this or not.
Yeah, I think that's basically the message, is that so the first phage integrated into the chromosome, GIFC3, it detects a second phage has started active replication, whether that's by infection or by activation from another place in the chromosome. It detects that because the anti-terminator made by that second phage turns on the transcription of a protein that kills the cell.
Q, right? Q
Yeah,
is made.
Q. Mm-hmm.
So one of my problems here is that when I look at this map in figure 2 of the lysis region, you've got the lysis genes with pokey in the middle. I'm probably, this is a little too much into the weeds here, but is that an operon? Is that going to be all on one transcript?
So
Because
usually, yes.
Because the impression that I'm given is that the Q protein acts differentially on pokey and the other guys. All right. But if this is an operon, I have trouble seeing how that's going to happen. All right. And they don't address that at all. I may be going, beyond things here.
If you're looking at the figures, figure 4C is really where they address that. So usually lysis genes that are clustered like that are an operon, and they'll all be transcribed together and on the same mRNA. But
they aren't.
In this case, it seems like they're not. What's a little confusing to me is how can you have your spanins off to the side and not transcribed at the same time?
Yeah,
but,
I mean, mechanistically, I don't see how that happens, but it does.
Their GFP reporters show that the first 2 genes, they do get turned on and made, and then it's not a lot. That's the last one where they use the GIFC3 Q protein, and they show that they get some GFP made, and they get some GFP made if they have the GFP after pokey and if they have the GFP after the spanins. But the key is that when they put GFP with pokey, just the pokey gene, and there's no spanins downstream, they get a huge increase there when it's just the BTP1Q. But the GIFC-Q doesn't have a huge increase. So it's...
Okay.
So even if pokey is on the transcript with the rest of the genes, here it's getting made independently. The BTP1Q makes pokey independently, so you get lots more copies of it.
So I had a question, and this has made us reflect my naivete about phage biology. But when I was reading this, it also made me wonder about superinfection exclusion and whether there was similar types of sensing of self-phage for superinfection exclusion. When I think about superinfection exclusion, I'm mostly thinking about removing the receptors from the surface. Yep. But I wondered whether there could be other things like this and whether there could be parallel systems for superinfection exclusion.
That is an area that my lab is super interested in. So I love this question. There definitely are more superinfection exclusion mechanisms than just removing the receptor from the cell. Various other steps inside can block a second infection. So a superinfection is where one cell already infected by a phage and a second phage of the same type infects. And so if we're thinking about this is how I think about it. It's like the first one is going to stake its territory, and it's going to say, no, this is my cell. I know that we are the same genetic material here. We're competing for the same resources. We're going to put the kibosh on the second infection. So that's the superinfection exclusion mechanism. It detects specifically the second phage, that it's the same type, and it prevents it from completing its infectious cycle. It can be by preventing the delivery of the DNA across the membrane. It can be by cleavage of specific proteins that are like early proteins, so that the second one that comes in can't move past the beginning stages of its infection. There are multiple ways of doing it, but usually we don't think about it as something that occurs this late in infection. It's usually a lot earlier.
Cool.
Okay. Well, that was, I really enjoyed that paper. Thank you for humoring me on the lysis mechanisms and marrying it with defense.
I feel like my lysis, lysogeny, bacteriophage lectures in my microbiology class this semester have just gotten such an upgrade. So that's very exciting.
Well, for me, this is as I communicated to Jolene on the side, this is a blast from the past because my PhD thesis was on an abortive phage infection that had some crossover with this. That I don't know if there's still an answer, to that particular situation. I'd have to look it up.
Yeah,
so I love this stuff.
Thing.
I want to know. So I know in eukaryotic cells, retroviruses do exclusion by putting up receptors, proteins that block the receptors. So once the retrovirus is in a cell, it'll put lots of gag on the surface that block receptors, so other viruses can't get in. But there must be other intracellular mechanisms, that I'm not aware of. I want to go look and see if I can find a good paper on that, because as we see here, there are intracellular mechanisms galore. I want to see them there must be in eukaryotic viruses.
Yeah, they did mention they call it effector-triggered immunity in eukaryotes. And I'm not but you're asking if HIV itself detects other HIV infections later, past entry.
Yeah, past entry or any virus. I mean, the latent ones are going to be the ones that, because they want to stay in that cell and not have another virus come. But an acute infection, maybe it's not as much as a problem. But yeah, these mainly maybe it could also be herpes viruses too. What if there's a latent herpes virus in a cell? What's to prevent another virus from infecting and killing the cell and putting a kibosh on the latent herpes virus? Right? There must be mechanisms, and I'm going to look for some because it would be interesting to do that.
I would be surprised if there weren't
of course.
virulent virus mechanisms of superinfection exclusion too. I mean, one of the phages that we're studying is a virulent phage, and it does superinfection exclusion at a later stage.
When I was a student, when I was first at Columbia, a friend of mine who was a student with me, he became a faculty member at NYU, and he worked on adenovirus, and I worked on polio. So we said, why don't we see what happens when you co-infect cells with adenovirus and poliovirus? See who wins. So we did that experiment.
Who won?
It depends who goes in first. So if you put polio in first, it shuts down translation. But if you give adenovirus a head start, it becomes resistant because adenovirus makes a little RNA that shuts down translation. So it actually reverses this shutdown. The cell shuts down translation in response to adenovirus. It's a global shutdown. So that would affect poliovirus. And then adenovirus makes a small RNA that reverses that shutdown. And so that would also reverse the shutdown for polio as well. But polio it's a very interesting story. But it's not, and I mean, these things happen in nature. You get co-infections all the time.
Yeah, right.
So there have to be solutions. Otherwise, one virus would always win.
Yeah, but it is sort of, I've always kind of wondered how superinfection exclusion really worked.
But when you have a lysogen, and we'll say, retrovirus or a phage, you have to have a way of preventing other viruses from crashing your party, right? Because it's your house it's my house, and you're not welcome. So how do you, and that's why there's so many mechanisms, right? It's very cool. So they have to exist.
It reminds me of
cells.
A quote from a movie. This is not science, but it is not always the stronger swordsman who wins. It's the one who has speed. Sounds like that applies here too.
I don't know. I would say smart. This is pretty smart, to have acute proteins of different specificities. That's brilliant. Well, evolution is brilliant. That's the thing.
You mentioned
if we continue our personification, yes.
You mentioned swordsman, and I go immediately to The Princess Bride.
I did too.
It's actually from The Count of Monte Cristo.
I think you're right. We don't care. We don't anthropomorphize viruses, and I guess we shouldn't. Evolution is a passive process, right? But it's amazing the kind of things you can get.
Yeah. I do think it does help us conceptualize what's going on, and then we can put it into proper scientific terminology.
Sure. I really enjoy the anthropomorphization or whatever it is. Thank you. I like to think of these things as having personalities.
All right, let's do some email. The first one, Rich, can you take that in? Yeah, you can. The second part is kind of longish, right? But just read his email, and then we'll.
Okay.
Because this guy knows you.
Hello, TWiV. I'm an avid listener and former PhD student at the University of Florida during the time of Rich Condit. My last name was Sack then. Brandon Sack, of course. Hi, Brandon. And I see that you're at Oregon Health Sciences University and apparently doing well. And congratulations. That's great. He continues, I owe a huge debt of gratitude to Rich's inspiration and advice, and a huge amount of gratitude for you all in making me look somewhat knowledgeable about viruses as a parasitologist amongst an institute of virologists. I'm writing to ask for your help in the unlikely event you are able, as the Oregon National Primate Research Center, ONPRC, has recently come under attack from the NIH director under the influence of RFK Jr., influencers like Laura Loomer, and unfortunately our own governor and university president. We do excellent work at ONPRC on many things, including infectious diseases, and are a true exemplar of animal welfare. Here's some basic information below, but the short of it is that we need people to write to our university board of directors, and he gives an email address, I'll give that at ohsuboard@ohsu.edu, with the subject line, for public comment. And he gives a link to an easy form letter if you don't have time. Comments are due by February 6th at noon Pacific, but that won't be the end of it, so continued support and awareness will help. Thank you so much for the work you do. Brandon, and his new last name is Wilder. And he gives some background. So I'd like to read the first part of this so that we know what's going on. Sure. Yesterday, we received news that our university president, Dr. Sharif Enahal, is seeking permission from our board of directors to enter negotiations with the NIH to close our primate research facility and convert it into a sanctuary. A bulleted list of what we know and useful information is below. In short, this is not a response to any concerns of animal welfare and appears to be the result of our president's conversations with HHS and the NIH, and is hastened by political pressure from our Governor Tina Kotek, a Democrat, following a smear campaign funded by PETA, P-E-T-A, and a Mercedes dealership owner. Not making this up. If you have time, could you please write a letter to our board and let them know your thoughts on this? I know everyone values non-human primate research to varying degrees, and it's totally fine if your letter says, yeah, shut them down. But it's important for our board to know where the real values and the real drawbacks are as part of this work. And then there's a bullet list of that describes basically the primate center and what it does and its value to the scientific community. So I was not aware of this, that there's
I had heard
campaign to shut this down. You know, primate research is a controversial topic. I understand. But as primate research centers go, this is absolutely one of the top-notch, most reputable
They do such good work.
Research centers that I know. And shutting it down would be a tragedy.
Yeah, I really wish I had known about this before noon, before the thing closed, the timing closed at noon Pacific today. But yeah, because I very much respect a lot of the research that comes out of this primate center, and this would be a real tragedy, particularly for certain types of SIV research.
Well, Brandon says that despite the deadline, this is likely to go on. So it's worth
Yeah, you can still
publicizing,
write, yeah.
and you can go ahead and make your opinions heard.
So one of the bullets is about the cost of converting it to a sanctuary. He says it would be $100 to $200 million a year. And he says, what's the likelihood that we're going to get that kind of money
Yeah.
from the current NIH, right?
Right.
Which is a good point, because I don't trust them at all. So it says here at the last sentence is, if you can speak to the reliability of the new NIH and HHS in general, that would be useful. Oh, yeah, we could speak to the reliability of that leadership for sure. So I just don't trust their, you have your own views on non-human primate research, but I don't trust HHS and NIH leadership at all. But that's just
Certainly
my
not
opinion.
to negotiate in good faith for a long-term project that involves
way.
scientific
And
research and the care of, they say, over 4,700
4,700,
animals.
yeah.
Yes, a lot of animals.
Yeah, it sounds to me like this is just sort of an emotional thing that's not the effort to shut it down. That
Mhm.
doesn't have any real foundation, reasoned foundation. And this bullet list is a good summary in support of the facility. So, at very least, this needs to be seriously reconsidered and well justified before any action is taken. It doesn't sound like that's what's happening. All right, Brandon, great to hear from you. I'm glad you're. I just love it. Love to hear of people that you've trained. Not that I had any direct, Brandon was probably in a couple of my classes. I remember interacting with Brandon. I'd love to see them succeed. It's great, and make contributions. So good on you.
Brienne, can you take the last one? We only have 2 today.
Sure. Charles writes, about my letter that was read on TWiV 1293. Hello, Twibbers. A bit warmer today in Chapel Hill. 41 Fahrenheit, 5 Celsius, no new rain or snow. About the Shkreli Awards, they are not something anybody would want to win, much like the Darwin Awards. The awards are named for a real ass, Martin Shkreli. He is known in pharma as Pharma Bro. His only contribution seems to be finding new ways to extract money from patients for existing drugs. He also made a bunch of money shorting Mankind, MNKD, with bogus complaints to the FDA about MNKD's inhaled insulin. The story is worthwhile for the real-life intrigue that includes the FDA, FBI, and insider trading.
Dun, dun,
We have a link for the Shkreli Awards and the link for the MNKD part of the story. About signing up for MedPage today, I picked other healthcare professional. Thanks, Charles.
I remember this guy now, Shkreli.
Yeah.
I remember there was a specific story where he was charging a lot for a drug or
I think it was
something.
insulin.
Maybe it was insulin. Yeah, he's a real jerk. Yeah. Oh, yes. Okay, thank you. So, yeah, I couldn't remember last time who he was, but yeah, I tried to sign up for MedPage. It was because I think Charlie had sent us to a MedPage article, and I didn't know. It said, "What do you do?" And there was nothing that fit me. Other healthcare professional? I don't want to sign up with that. That's not me. I'm not an other healthcare professional. So I'm not going to sign up to MedPage until you fix it, MedPage, as if they care.
So he's a co-founder of a hedge fund, and co-founder and former CEO of pharmaceutical firms Retrofin and Turing Pharmaceuticals. In 2015, it was widely criticized when Turing obtained a manufacturing license for the antiparasitic drug Darmaprim and raised the price to insurance companies from $1,350 to $750 per pill.
I remember that.
Sparking
Yes.
a scandal.
Wow.
Blah, convicted in federal court on 2 counts of securities fraud. Blah, blah, blah. Yeah, he's a winner.
Amazing. It's just amazing what people do.
Yep.
No remorse. All right, let's do some picks of the week. Brianne, what do you have for us?
I was inspired by the past few TWiVs I've been a part of. People have been giving great book reviews. And I have been getting such a great list of books to review that I decided that I was thinking about my book collection. And a friend introduced me to this app, Libib, that lets you catalog all of the books you have. And so I actually have this app. It has a barcode scanner. And so I can just open up my phone and scan the barcode of my books, and it makes I have a full library list of everything I have. And so I have a full list of my library that I have at home, in my office. I put books that I'm interested in reading in it. And then, like, if I'm at a bookstore, it's really easy to pick up and kind of look and see what I have. Or if someone is looking for something, it has it there. And I find it very useful and very good for organizing all of the books I have. So if you're learning about all these great books on TWiV, and have a huge library like I do, this could help you collect them and archive them all. It does like DVDs, it does board games, it does a lot of stuff.
So will this actually help me organize them as well into like categories?
Oh, gosh.
I have not seen it do that. I
Okay.
just like to remember what I already have and if it's in my office or at home.
Yeah. Okay. My big issue is that people recommend books to me and then I forget about them. Okay. So it'd be nice to have, but I'd also like to know, okay, which of these are sci-fi? Which of these are biographies or whatever?
Yes, I have not had it do that, but
Okay.
I do have, because it lets you set up a few different libraries, and I just made one books I was interested in.
Cool.
Cool.
That is so
Rich,
nice.
what do you have?
Speaking of books, I confess I have not yet finished reading this book. I'm, probably 75, 80% of the way through it. But I know I'm going to finish it. And I can't give you a spoiler alert, and I think it's spoiler capable. This is called The Mysterious Case of Rudolf Diesel, Genius, Power, and Deception on the Eve of World War I. And it's by Douglas Brunt. Very well written. And it is about the life of Rudolf Diesel, who invented the diesel engine. And it's pointed out early in the preface that diesel, as in diesel engine, needs to be capitalized. Said, would you talk about a Ford motor car without capitalizing it? Right?
Mhm.
Yeah.
And for those who are not aware, the diesel engine, the fundamental principle is that it fires with it's an internal combustion engine that fires without having added spark, simply because the pistons compress an oil to a point where the heat rises within the cylinder because of the rise in pressure and burns the oil, okay? Makes it explode and gives the mechanical force. And I didn't realize that diesel engines, I'm sure they're a little more picky now, depending on the engine. They can run on all kinds of oil, right? So in the World's Fair, where this guy first demonstrated this, he had a bunch of diesel engines running on peanut oil. So think, biodiesel, right? You can make oils that will work in a diesel engine from strictly biological products. But, so the deal is two things. First of all, the history here is great, and it's very well written. We're talking about the turn of the 20th century, when steam power has been around now for a few decades, which is external combustion, right? You heat up water to steam, and the steam then separately drives either a turbine or a piston engine. We're converting, and those are really not very efficient at all and huge, so that you have to have these big industrial centers where you have one big engine that runs a whole factory and that kind of stuff. We're moving from there to internal combustion engines, and the gasoline engine and the diesel engine were invented roughly at the same time, but the diesel was a better product. And it talks about how the diesel engine just kind of took over the world. And contrary to diesel's idealistic visions of bringing energy back to rural areas so you could do small manufacturing, diesel engines wound up being used more in military than anything else. And this is at the beginning of World War I, so diesel is in a sort of an awkward position. It turns out that he died at a young age, about 55, during a crossing of a boat to the English Channel from Antwerp to London. He disappeared overnight, and a body, badly decomposed, with some artifacts that were identified as his, were discovered 2 weeks later. But it's always been a mystery as to what happened, whether he committed suicide. There are some people who think he was murdered because of various circumstances surrounding his engine and the role in it. The book purports to shed new light on this. I haven't gotten there yet, so I can't spoiler alert it for you. But it's a great biography. It's a wonderful description of the evolution of the technology during the Industrial Revolution, and it's got a mystery aspect to it that I'm getting to, so I recommend it.
So a diesel is a 4-stroke. The piston goes down, pulls in the air, then it goes up and compresses it. Then they spray in fuel. It explodes. The piston goes back down, and then it goes back up on the exhaust cycle, pushes out the crap, and then you start all over
They
again.
talk about there is in the process of this a 2-stroke diesel engine that was made. I don't know if those are still in practical use or not, but you're right. By and large, it's a 4-stroke engine.
Of course, the diesel revolutionized the railroads, right? Because we used to run steam engines, and then they were all converted to diesel, which now are gone. Most of them are electrified, except the train I run on, the line I run on, is not electrified. And so they still have diesel engines, and they come rolling in the station making that noise, which is really typical of a diesel engine. And you know what's really interesting? The diesel engine does not directly drive the train wheels, okay? That would be too much torque. The engine would flip over from the torque it would take to move the train forward. Rather, the diesel runs a generator that makes electrical power, and then there are electric motors that drive the wheels. That way you get around this torque.
Well, a big feature in this is submarines, because diesel engines made submarines a practical war machine.
In hearing about this pick, I'm not sure I can even describe how many things I just learned about as you both talked about that.
Well, that's why I like the book. Okay, it's got all this stuff I never thought about. Oh yeah, diesel engine. It's just a kind of engine, right?
Brianne, the train you take is it probably has a diesel. It's not electrified, right?
Right.
You take the Raritan Valley line?
No, I take the Morrison Essex line.
Is that not? That's not electrified, is it?
I don't think so.
Yeah.
The other guy who comes into this story is John D. Rockefeller, because while this is all going on, petroleum is just being developed as a commodity, and that feeds into the whole diesel thing ultimately. And John D. Rockefeller, of course, is at the center of that.
Cool. Jolene, what do you have for us?
So I'm picking the artwork of Ellie Jameson, who is a lecturer at Bangor University in somewhere in the UK, Wales. It's unclear to me because a couple of the places where I look say different things, but she's definitely a phage researcher, and she co-leads a program that's looking for phage in a One Health kind of research theme and antimicrobial resistance, and she's an artist. She has this wonderful phage art, and I think I got to know her because I bought some of her artwork printed onto products on Redbubble. So I'm giving a link to her Redbubble store. I love her steampunk phage, and every October she does this Inktober, it's called. And so she'll draw a bunch of different phage themed artwork. Some of my favorites are things where like there's two bacteria facing each other, and one of them has a bacteria shaped shadow and the other one has a bacteria phage shaped shadow, and the one with the regular shadow is like, the other one is infected. All kinds of really interesting and cute things. So there's like a phage themed snowflake and lots of just little descriptions that kind of get at the science and the humor behind the drawings. So I am linking her website, her WordPress website, where you can look at the menu and it'll show the different years that she has done Inktober. And that's my pick.
These are really
I
cool.
love
I
the
like this.
steampunk is really cool. I love that.
I really
I'm
like
looking-
some of these. This is cool.
I'm looking for the steampunk.
Scroll
Right at
down
the
on the
top.
WordPress.
It's also in the header, right, all the way at the top. All right. A couple of weeks ago, Brianne picked a book by Blake Crouch. That was
That was Dark Matter. Yeah.
Dark Matters, which is very. I just bought it while you were talking about it. I don't know why, but I read it, and I read books now on the train. I read it in 2 days, and it's all about how quantum physics predicts that there may be forks in history, right?
Mm-hmm.
So every time there's a fork, you have different parallel things going on, right? And this book has a character who exploits that. Really interesting. And what I found cool, so there's science behind it, right?
Mhm.
And that's really cool. But also, there's something about his writing that just totally sucked me in. And then when my train arrived, I'm like, where am I? I have no idea where I am.
Isn't that
So,
wonderful?
I haven't had that experience in a
it's
long
wonderful.
time. So I decided to buy another one of his books called Recursion. I don't know why I picked this one, but this one has got a big neuroscience background. Oh, you did it again, Jolene. You moved your mic, and now you're recording on a new track. And yep, you're back to the brio. So we're going to leave it there. So this one is about neuroscience and memory, and in the same way that Dark Matter dealt with quantum physics, this one deals with memory, in that you have lots of old memories that you could, and someone develops a way of exploiting that, of going back and reliving old memories. It's just, it's even better than Dark Matter, Brianne. Did you read Recursion?
I have not, but I've seen it. I think I have it on a list somewhere, and so it's now moving high up that
you
list.
got to read this. It's really, I just finished it yesterday, and I mean, this idea that you could just go back and relive things if you don't like the way they turned out. So this neuroscientist, this lady, develops this mechanism where you could go back and redo something. So, and then if it gets in the wrong hands, you can imagine that you could prevent World War II, right?
Yeah.
You could just go back and kill certain people. Oh my gosh, the implications are amazing. And so the book is all about this scientist figuring out how to go back and not do her invention because it's screwing up the world. And so it is just unbelievable. He's a really good writer, but I'm resisting the temptation to read more of him because
I know
that'll
I've read another
diversify.
short story by him that was good.
He's a very good writer. And he makes, and this one is like the same. It pulls you in. You don't know where you are. I like it very much. I like a good writer who can do that.
Yeah.
All right. That's TWiV 1295. The show notes are at microbe.tv/TWiV. If you have any questions or comments or picks, send them to twiv@microbe.tv. If you enjoy these programs, we'd love your support. microbe.tv/contribute. Jolene Ramsey is at Texas A&M, ramseylab.vercel.app. Thank you, Jolene. Hello? Can't hear us?
Oh, Jolene,
She's frozen.
Vincent just
no, her
thanked
eyes
you.
are moving. Her eyes are
She
moving.
look in the chat.
Thank you. This was a lot of fun to talk about phage, and I am glad that we were able to really get into some of the nitty gritty, but also just think about the population level things. So I hope to do it again soon.
I guess you can't hear me, right, Brianne?
That's what it looks like.
Okay, it's too bad. Well, we had we originally got Jolene to join us to do phages, so she can't do anything else, I guess.
No.
Brianne Barker's at Drew University, BioProf Barker on Blue Sky. Thank you, Brianne.
Thanks. I learned a lot.
Rich Conda is an emeritus professor, University of Florida, Gainesville. He's currently in Austin, Texas. Thank you, Rich.
Sure enough, always a good time.
I'm Vincent Racaniello. You can find me at MicrobeTV. And what does that mean? You can come here and visit the incubator. I had 2 visitors today to the incubator. You can do it. Just email me. I'd like to thank the American Society for Virology and the American Society for Microbiology for their support of TWiV. Ronald Jenkins for the music, and Jolene Ramsey for the timestamps. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.